All right, the very first thing I need you to do in here is I want you to actually go to python.org, and we are going to install Python. You can use this on your own computer. I'm going to show you how to do it. We're in the lab here right now, but you're going to be doing it on your own computer, so you'll have a place to do this with. So most of you have Windows PCs by a small majority. If you have a Mac, it works very similarly, and we will show you how to do that. So this is kind of the motherland of where Python lives. These are the people that do all the development on Python. If you want the authoritative answer on how to do something on Python or how not to do something, or you have a question, this is kind of the motherland, the homeland for Python. All development is pushed here. Here's the best part about Python for us, because we're all broke college students at heart, is it's free. So if you'll follow along with me, and you can do this in the lab and on your own computer, we're going to download and install it. And so we'll have the latest version of Python. So it's going to be different than what your book, and even if you have some references to last year, if you find a video from last year from me, it's going to be slightly different because they continually update it. So I need you to click on Downloads. And when I hover over Downloads, notice it says there's different versions for Mac OS X, other platforms. But the one we're going to grab is the 3.8.1. And notice it does have a warning. If you still have Windows XP, because you have not updated for a long time, you are stuck at 3.5. Realistically, 3.5 for everything we're going to do would work, and you can certainly go download it. You would get that over here on Windows, and notice it has older versions and all different kinds of things on it. But I'm going to go backwards again, and I'm going to click on the Python 3.8.1, and I'm going to download it. And it should take about 20 seconds to download. It is a fairly small program. Once it is downloaded, you're going to actually run this program. What a surprise. So right now it's still up. I've got Chrome and it's here. It would also be in your downloads folder. I am going to leave the defaults alone for now, and I am just going to click Install Now. You'll get a verification. Do you really want to do it? The Windows UAC pops up. I clicked yes, and now it should install this file fairly quickly. And it should take about 35-40 seconds for it to install. It's pretty simple. So the first half of our class, we lived in the Notepad world, and we're writing this pseudocode. Well, now we're going to start getting into actually writing this as code, and you'll see what we're going to look at here pretty quickly. So yes, you do need to click yes to authorize it to install. So again, your computers in this lab are quicker than this one up here. And it should say setup was successful. And it's even got some tutorials and things. And we'll look at those tutorials, but not right this second. So what I'd like to do is, that was pretty quick and painless. So we've got that installed for most of us. You can find copies of this for almost any operating system. Python is kind of handy and unique in that it's very, very cross-platform. If I want to make sure that it is installed, I'm going to do this. I'm going to hit the Windows key, and I'm going to type not Python, but IDLE. And you'll see that the Python idle environment pops up, and that should look like this. It popped up on my other screen naturally. But if I type IDLE, this is the development environment we're going to use. If I look at all programs on my computer, you'll see that it's installed. If I go to P for Python, hang on a second. So you'll see that there are several different versions. I've got several different versions of Python installed. So these all show up as new. But the thing that I'm going to most often run is I'm just going to type the words IDLE. And IDLE will be that shortcut to this environment that we're going to look at right here. All right. So this is where we're going to head to. So that's not too tough. And right now, this is the environment we see. There's not a whole lot to it. We're going to look at last week's homework first and kind of work our way backwards here. So, all right, we'll worry about that here in a second. So, all right. So, there's an older version on there, so I'm not too worried about it. All right, so we need to install Python in whatever computer, whatever language, whatever module you're going to use on. So again, there's ones for almost anything we want to look at. So last week's assignment, if I go back to week 4, you had an assignment, and it had a debug program in it. So I will post the multiple choice answers so that you can see what they should have been. So this was your debug program. And this debug program was set up to originally create, it says, all right, I'm going to create a mailing notice for your bank payment. And mortgages are these fun things that you will get, and in some cases, those mortgages can go all the way out to 30 years. That's a long time to be paying on something. So in this case, it goes out to 12 years. We also had every month. So you get a monthly bill that says, hey, here's your payment. Make sure you pay this. So when I look at this, it looks a little ugly to start with, but I should see that I have that idea of I need an inner loop and an outer loop. Just like we built our clock, now we're going to build an inner loop and an outer loop. Well, to start with, there's no indentation in here. There's no blocks. I don't know what's going to happen at any particular moment. So I have number of months equal to 12, number of years equal to 30, and I have a message in there that says, remember to allow 5 days for mailing. I have some variables in here, maybe, sort of. So I set number for month counter, so it's a numeric, and I have year counter is equal to 30. And then I have these while statements. So I see two whiles beside each other. So I think we're supposed to nest them, but not really sure because that's just kind of ugly all the way around. That's the kind of code you interpret and you look at and you go, what am I going to do? And you need to fix this so that it will be a workable piece of code. So the first thing I'm going to do is I'm going to set in here and I'm going to do some indents to hopefully make this a little less ugly. And the start and stop, we really should indent the entire thing. But we don't have an easy, let me pop it back on the screen. We don't have an easy tool to do that, so I'm going to temporarily leave those alone. What should we probably do first to kind of, where do we want to start indenting so we know what's going on here? So I'm going to at least make some white space here so I can kind of see what's going on. So here's my declarations. So I declared months, years, month counter, year counter, and I think those, when I capitalize them all, that I'm supposed to have those as constants. Well, that makes sense. Months is probably equal to 12 months. And our years is equal to 30 if we have a 30-year note. So that makes sense. They're going to print 360 payment coupons, one a month for the next 30 years. Ooh. So these two lines are probably correct. I probably don't need to change a whole lot about those particular lines, unless we want to change how many years. It doesn't make any sense to change the number of months in a year. We know that that's 12, or should be 12. And this message, well, that makes sense. We're not going to change that. None of that's going to make our program not run. We also, though, have a couple of counters. So we have a month counter and we have a year counter. And when I look at those, my spider sense says there might be something a little hinky, since one starts at 0 and one starts at 30. The one's at the bottom of its range, because that month counter should range from 0 to 11, since we start counting at 0. And the year counter should go from 0 to 29. But we're at the top end of its scale, so maybe we're going to have something that's going to happen here. And then here we have our while loops. So a while loop, everything inside of a while loop needs blocked out into an indent if it's part of that loop. Right now, this is going to run a while loop, and the computer isn't going to be able to recognize that there's actually supposed to be anything happening inside of that while loop. So the first thing I'm going to do is take the first loop, and I'm going to tab everything that I think belongs in it. So while counter is less than years, or less than or equal to years. All right, all these things are going to happen. This while loop, I think what it's trying to do is output the month counter, year counter in a message. And I think this hopefully goes into there. So now that I've indented it a little bit, I can start to see maybe we have something a little better going on there. All right. So now I see the outside loop here. So everything contained in here is based on years. And it says while it's less than or equal to years, while month counter is less than or equal to months. So is there anything I need to change on that outside loop? So the easy way to do that is put some numbers in and see what happens. When I first come through this loop, my month counter is equal to 0, and my year counter is set to 30. So while year counter less than or equal to years, so while 30 is less than or equal to 30, as I look back up at its value, that inside loop is going to run once. So here goes our inside loop. It runs, and it outputs the month counter, which would be 0 month, and the year counter would be year 30, and this message. Well, that seems really weird to start with, that we're going to start printing at year 30. So what's the first thing we might need to change on this? You could count either up from 0 to 30 or from 30 down. So what I'd like to think, though, is you're going to print this coupon book, and they're probably going to use the first years first. Or if this is setting in a program where it actually has to wait for a time element, so I would think we would want to count up from year whatever we're going to pick to year 30. And we have a couple of decisions to make how we're going to do that. So for the computer, year 0 makes sense, doesn't it? But if I just change this, so let's just make a simple change here, and I'm going to change that to 0. So if I change that to 0, so now we're going to go through and it's going to be this first loop, it's going to come in and it's going to be 0 is less than 30. Month is going to be 0 less than 12. So the inside loop will fire off, and the inside loop will count up. So it's adding month counter plus month counter. This inside loop is actually going to run how many times? So let's think about what's happening in there. That's where we need to think about. So we have a lot of different ways we can fix this. There's not just one way to fix this. So if I have that as month counter less than or equal to months, and I start at 0, how many times is that going to run inside for months? Well, let's think about it. 0 is going to pass through, right? When I count all the way up to 12, is 12 going to also pass through? And the months from 0 to 12 are actually 13 months. So unless we're going to add an extra month, we also need to solve that issue. So there are a lot of different ways we could do this. I'm going to suggest we do one just to make it easier for us to read. In this particular case, our computer doesn't give a crap. It doesn't care. But this might make it easier for us. What if I set the month counter to 1? So it starts at 1 and goes to month 12. Because that's how we typically describe our months. This might be an easier output. The output will look like what we're used to. So January will be month 1, February month 2. Otherwise, we'd have January is month 0, and we'd have to have some accommodation to understand that. So we're going to cheat a little bit, and we're going to say month counter equals 1. And so now when we go through this, it's going to start with 0, or we're going to start with 1. So 1 is less than 12. It's going to output month 1, year 0, and its message. Add 1 to the month counter, and this loop will run 12 times inside it. Our outer loop, though, is going to run from 0 to 30 years, so it's going to actually run 31 years if we go from 0 to 30. Well, we don't want that. You don't want to pay an extra year's worth of a mortgage payment. So I'm going to do the same thing up here. I'm going to start those, for our convenience, not the computer's, at 1. Now that outside loop will run from 1 year to year 30. Or will it? There's at least one other kind of big problem in here to start at. What's our big problem in here? So think about this outside loop. So the outside loop runs, well, year counter less than years, so 1 is less than 30. The inside loop runs 12 months. It exits out, and we start this while loop again. Yeah, we're right now, this would run forever on whatever year we started, because we don't have anything in here to change the year. Now that year has to come after this inside loop runs, because we don't want to change it with the inside loop. So here we're going to have year counter equals year counter plus 1. So now this loop should run 12 times on the inside for every 1 year on the outside. So the total number of times this message is output is the number of times the inside loop runs times the number of times the outside loop runs. Or in this case, 12 times 30. So it should create 360 messages or envelopes or whatever it is we're doing to output for this mortgage. So let's take this one step further. It would be really weird to me. We know months are typically 1 through 12. We're used to that convention. But if your mortgage payment said year 1, year 2, year 3, would that be really confusing? Is there a way we can take this and output the actual year? So you want to change this up here? You just want to change this to something. Okay. So I make the so let's do. I see where you're going. Let's try something just slightly a little different from that. What if I did? Maybe we added a new variable in here, and we could call it numeric end day, end year maybe. And we're going to set that equal to years plus. Now, we actually will have functions to pull the current year and such, but for our purposes, let's just put in 2020. Now, right, and that's what we're looking at is the start year and the stop year. So we could actually create one that said, so now this counter, year counter, is less than or equal to end year. So while we haven't hit whatever that end year is, it's still going to go. But we need to start that year counter at 2020. Now that's kind of a magic number, so we'd probably really want to put in something where this variable and this variable, maybe we do it this way. We call it, and we call this one, so we're also is equal to current year. And up here we have, maybe we even input it or we ask it. So we say numeric current year equal input ask user for year. So something like that. So whatever our current year is, or we can pull it back out of the computer. But this way, that output says output month counter, so it'll output month 1, and the year counter will actually be a correct year. So are there any other major problems in there that we see? So this inside-outside loops, the loops inside of each other, are one of the harder things to wrap your heads around conceptually and look at it. So one of the things I have done is I wanted to show you how easily we can convert this into a Python, into our language. So if you will look at week 4 or week 5, where did I put that? There is one here called Python sample which is what I was trying to open up earlier. And so if I open up this Python sample, I'm going to save it. And notice it's a different file name. So Python code is stored as .py. So it's a brand new type of file name. I'm going to keep this file, even though Windows will yell at me. And I am going to go find it where it's hiding in the folder. So it's in this downloads folder. So I've just downloaded it. And it's stored as, in this case, because I've downloaded it twice, it's chapter 5 sample.py. If I click on it, it'll actually run, but it's going to do this. And if you click on it and run, it comes up in a text box, it runs really quick, and it ends. And you don't see what it runs like. So what I want to do is look at it. So I'm going to right-click on this, and I'm going to click Edit with Idle. And I'm going to come over here, and it really doesn't matter. I've got 3 different versions here all ready to go. And I'm going to click Open. So this is that same code that you looked at over here. So here I have, let me put it over the top. This is kind of my same code. And I just wrote it really quickly in Python. Now, are there some things I didn't do really nice and neat in here? No. I did this in like 3 minutes to show you how quickly it would look. So, does that look a lot like what we're already doing? Python is so English language. So here I set up months, years, and I set up a message. Please allow 5 days for mailing. Month counter equals 1, year counter equals 1. Same way I showed you. And then I have my while loops here. And that while loop has while year counter less than or equal to years. The one difference in here, you're going to see. Thank you. Did it pop up for him? If you just run it, it will run as a black screen. You have to right-click and go Edit. All right, we'll deal with yours here in a second. Just hang on. So I got a lot of stuff I want to throw out today. So can you slide around and take a look at Dwight's and see what? So this looks a lot like. So the one thing that Python doesn't do that we do in pseudocode, well, there's a lot of weird little differences. But notice I have explicitly in my pseudocode, I say end while. In Python, I don't have that. It tells that it's the end while because you're back to that level of indent. And so when I keep stressing those indents are important, this is why. Because it says that that second while loop, that inside loop, is all done, and the only way it knows that it's inside that loop is because it's indented that tab stop in there. And so in this case, I actually have this piece of code up, and we're going to run it really quickly now. So this is pretty tough. We're in the idle environment. We edited it, and I'm going to run this by clicking and see if I can see it up there. I'm going to click the Run button and go Run Module. And so what it does, it pops up, and now it's running through there, and so it's going to go to 30 years. So remember what we looked at. So it's month 12, year 30. Remember to allow 5 days for mailing. So it has ran through 360 lines of putting that up on the screen. So we could test that theory that things are going to break. So if I wanted to see, hey, what really happens if I do this with a 0 instead, I can go back here and I can change this. And this is one of the little quirks in Python that you'll see. We have some other ways to do it, but the way we're going to start out with, you're going to have to save this file before you can do anything with it. And in fact, if I try to run it, happens to be F5 also, it says source code must be saved. Do you want to just save that? Well, in our case, it's okay. But if you've made major changes and you want to make sure that you have some versions, this can also be a problem for you because you may have wiped out all your good code and replaced it with something not so great. So we'll work on versioning here. But I'm going to save it. And now I've run this, and we'll see what happens. Ah. So why did it do that? Let me look here. So at the very top of that, so it doesn't say, oh my goodness, you ran 31 months, but what it's going to do is start at 0. And so we have month 0, year 0. So you're adding it at the top, but it's actually run. If I counted those, you would see that it actually just added another year on there. And we can even do some really quick things. If you want to test something, I can create a counter. So Python's really great about this. I could just call this counter equals counter plus 1. I want to know how many times this inside loop runs altogether. And then at my print statement, I'll just add the phrase counter. There's one little problem with this, and I'll show you here in a second. But this would then no, I didn't define counter outside of the loop. Hang on. So now at the end of that, it's telling me how many times that inside loop has run. Oh, 372 times. Well, if you signed up for a mortgage for 360 payments and your bank sent you out 372 notices to pay, are you going to be mad? Yeah. I'm mad every time I pay my mortgage payment. And I'm paying what I agreed to. So that's where we have to be careful with how we start and we count. But this is your first piece of actual Python code we're looking at. It doesn't look that tough, does it? No, it's very English language. But it is also very dependent on these. Come back, where's my mouse? Mouse, come visit me. It's very dependent on those indents. And this is a very different problem. So this counter here that I'm playing with, if I move it in an indent, watch what happens. So that simple change means it's running on that outside loop, not the inside loop. And it says that outside loop ran 30 times. It doesn't tell me anything about the inside loop. And that's that simple indent that can make life miserable for us. And I might want to know how many the inside loop and the outside loop runs. But I can, just that little tab, that's what I'm trying to show you is how quickly those change just by that level of indent. So if I have 4 layers of loops, so I'm doing a clock, for example, I have to be very careful about where those indents are. You'd have to make 2 counters, and you could do that. So we could call one a counter on the inside and a counter on the outside. So we could do that. So in fact, we could explicitly call them outer counter. And so this would be outer counter plus outer counter. And then we could do an inner counter and then we could put that in there. I see where you're, hold on a second, I'll show you. So this inside the parentheses is just saying what we're going to print. So right now, we're going to print inner counter, outer counter. So these are just variables that we're printing. We're printing the month counter, year counter, message, inner counter. If I can spell it. There we go. All right. I was trying to look how I had spelled it up there. Inner counter, outer counter. So now it'll give me a display for inner counter and outer counter all together, hopefully. And so now, off on that right-hand side, it's showing me how many times the inside runs and how many times the outside runs. So 372, 371, that's that inside one. But notice this stays the same for, well, in this case, 13 iterations, because we messed that up. But so the best part is we can do all these. Once we get ready to put that code and show it to somebody, I can just delete out those. Or in fact, we'll show you how to use comments, and we can take those out really easily. So Python is pretty simple. My loops look exactly like they did in my pseudocode. I have my constants here that are capitalized just to say months, years. My message is just message equals, and the only difference is I put that in quote marks to show that it's a quote string. And I could change that from your friendly neighborhood. Now I broke it though. Notice what happened? So when I hit that extra line in there, what happened? So notice the color changed, and that color says, oh, that's not part of your quote string anymore. So I have to be careful with things like that. If it's not color-coded right, it's probably not what I think it is. I got hiding in there. I put a lot of junk in there. So if I don't put that in quote mark in, Python doesn't know when that text string ends, and so it might consider part of your next line part of that also. So we can change things up pretty easily. But this is Python. It's not really super scary, and it runs, literally we have to save it, and then we can run that file. And I can run this file, and we'll show you how you can fix this, but if I run it, it pops up in a little text box. But we'll show you how you can make it run without going into this idle environment. But this is our editing environment right here. This is Python idle. So you'll need to know how to get into idle, because that's where we're going to do the majority of our editing. Now, I can edit this Python file in a lot of different things. So I'm going to close this. Yes. No, I don't really care. All right. I can edit this because I can actually open it with Notepad++. I can open it with Notepad, and in Notepad it looks exactly the same. Same thing we've been working on in Notepad. The advantage to that idle environment, it gives you the color coding for some different types of objects. We'll show you what Notepad++ does, and it gives you a couple of advantages. But I can edit that file in about anything. If I'm on a Linux machine and I really want to go old school and I want to do it on a command line, I can do it in VI or Max. Easy. I can do it on almost any text editor. What will screw it up is trying to use things like Word. Word is not where you want to be on this. So when I save this, if I'm in a text file or text editor, all I have to do when I save it is say File, Save As, and instead of saving it as a text document, I change that to all files, and I make sure it says .py. That's all I have to do. So anything that ends in .py, automatically Python knows about. Here's the one problem for those of you, I see some Macs in here, and I know people are using them. Macs tend to not put extensions on automatically, so you have to put it on for it. So if you send a text file, a lot of times it just drops off the extension, because Macs are a little smarter than Windows machines, and it will try to know what a file is without that extension. So that is our friend Python to start with. So to install it, all I have to do is go to python.org. Oops, where have I got python.org? Somewhere I've got it. So everything I wanted to know hiding up here in Python. So there are everything from tutorials, help features. If I want to know what a function does, so I want to search out the print function, because that's all brand new to me. Now you can see every kind of function and change things that you can do with print. So the one downside to this being the authoritative site is sometimes it's not always the easiest to use. So there's the downside to that. But there's how to start, how to work with it. The one thing I want to make sure you get is make sure you get Python 3 dot something. I don't care really any of them. 3.2 will work, 3.3 will work, 3.5 will work, 3.8 will work. Whichever version, make sure that it's 3 dot something. There are a lot of websites that have 2 dot versions out there, and there's a big changes from version 2 of Python to version 3. All right. So let's go back and look at our week 5. What kind of goodies do we have this week? So we're going to look at something called arrays today, and we're going to start on arrays. Arrays are either the most helpful thing you've ever seen, or they're going to be the most confusing thing you've ever seen. I think they're super helpful. The way the book explains them, I don't think is necessarily the easiest way to explain them. So, if you will hang tight with me, I will try to make this as painful or painless as possible. So, our book talks about arrays. Arrays are really another way to look at variables. So, it's a set of variables that we control all at once. So, an array typically has all the same data type. So they all have to be numerics, or they all have to be integers, or they all have to be text strings. And how we reference them then is we reference them with the same name, but we use a subscript or an index. So this sounds really weird. So when we declare an array, we're declaring that we're really putting together a set of buckets. And I like to think of it as a set of buckets. So Excel is a handy way to do this without using my drawing skills. So I'm going to create a set of buckets. And I'm going to do this for months. I'm going to call this array months. And I'm going to declare this array, and I'm going to say, all right, I'm going to declare an array called months. Well, we know a little bit about months. And we know that months have a certain value. And so, how many months do we have in a year? 12. So I'm going to declare an array, and I'm going to declare an array of size 12. In other words, it's going to have 12 buckets in this array. And in that array, then, I'm going to have these 12 containers. So I can get up to 12, 9, 10, 11. All right, and notice I stopped at 11. Those are the subscripts. So if I want to find what's in that bucket, I'm going to say month subscript 1. And I'll pull the value of whatever's in that bucket. And in this case, not only am I declaring it it's a size 12, so in other words, we have 12 buckets, we're declaring that we're going to keep strings in it. Strings are data that is not numeric, in other words. It's got a value, but we can manipulate it a little bit. So I'm going to put in here January, February, and so on until I get all the way through those months. And I see if it'll auto-complete this for me. Ooh, look at that. Thank you, Excel. All right. So when I call, so I'm going to say, I want to get the value. So I say print months. Our computer always starts counting with 0. So when we declare an array, it always starts with 0. There's no way around this when we're working with arrays. Our computer always starts counting with 0. That's its number that it starts with. We have to deal with that. So if I say print months, and I'm going to pass in the variable 3 as that subscript, this should then print whatever is in variable 3 right here for April. We've declared that that's a bucket. We're going to store things in it. And it lets us use this in a very handy way. So I know what the months are, but this lets me manipulate them by number. Now, again, I have to remember that it starts at 0, so I have to do that translation in my brain. But I could also do an array that stores numbers, and I can store all kinds of other things in there. All that an array is a set of buckets. We declare where it's at and how long they are. The computer can only store zeros and ones, and we're really chopping up little sections of its memory and saying we're going to store things in this memory. So an array is nothing more than a set of buckets that we store data in. So I want to look at what they do. This something very similar, and they say, all right, some value for 1, some value or for 0, 1, and 2. They're just a set of buckets we're storing in our computer. Depending on our language, we may have to say how big that bucket is for each one. Is it big enough to store an entire text message, or does it store just an integer? So we have to have some. Python, luckily, is really nice to us about how we do arrays. But other languages are not so nice. We have a little more declaring at the beginning. So these arrays are a way we store data. So here we declared an array. We said we have some values and we're storing 3 buckets. So the same way I did with months, we stored 12. They're only going to store 3, and that's 0, 1, 2. Sometimes we can even cheat and we can put it all in there at one time. So we could say some vals 3, and we put in the values 25, 36, 47. Python lets us do that. It's kind of a handy, quick way to do that. So that subscript in there becomes really important because we can manipulate that subscript number. We don't have to just put in a hard-coded number. I can put another variable in there. So if I wanted to print out the entire list of that array, I could do it by running a little while loop, changing a counter, and putting that counter back in as the subscript. I know, this seems crazy. So, the book talks about all these decision making. I think it's easier to look at really how we store that data and we can use it. So they talk about dependence, and I don't really like that nomenclature. I don't think that necessarily helps us a lot. What I want to think about is arrays where we can store data, and in fact, it's kind of the basis for how we start storing things like a database, because I can manipulate how to get into and out of those buckets programmatically. I don't have to have a separate variable for it. So think about if I declared an array for everybody's name in this class. I don't have to have a separate variable for all 28 people or whoever is all enrolled in total. I can have one variable with subscripts for everybody that goes through there. And it really does make life a little easier. So, even here when we declare an array, sometimes it's a lot easier for us to declare a variable to move it in there. And then later on, if we need to expand it, we change one variable instead of hard-coded values in our program. So I know some of the programs I've shown up here as samples, we put hard numbers in, like for months and different things. But we're better off using variables anytime we can. So this allows us then this ability to search through a loop. So this is where it gets a little complicated. So if we want to search through a loop, so here's an example of a piece of code that shows how that we can search through there. So if I look, and I know it's a little small, we declare a whole bunch of things, and we declare one called valid item size. So size we pull from above that. So we have a 6-element array. So we have 6 buckets. So we're going to look at those sizes are 106, 108, 457, blah, blah, blah. That could be anything. What we are going to do, though, is we write a loop. So here we write a loop to see if we can find that element in our loop. So this could be a list of all of our lawnmowers. Maybe we're running a lawnmower company, and I want to know if a particular lawnmower, if we own it. We could look for it. Here we're going to look for, so we have a subscript here, and we actually just call it subscript 0. So we start with that. And here was our loop. As long as sub is less than size, so size is equal to 6. So as long as this value is less than 6, this loop continues to run. So the first thing we do is we come into this loop and we compare, is your item equal to valid item? And valid item subscript, so it's valid item subscript 0, which is equal to 106. So if that is what we're looking for, then that loop would say, all right, yep, it's true, and found it. So we have a flag or another sentinel value, flips to yes. We add sub equals sub plus 1, and we continue that loop until our loop ends. So this is a linear search. It's not necessarily the most efficient, but it searches through. So we're making some comparison throughout that entire thing. So in here, you declared item, and so maybe you said, I want to look for item 307. So it's going to loop through once, and it's going to say, well, 106, because sub 0 is 106, that's not it. So adds 1 to it, loops around again. Now it's at subscription or sub 2, so 108. Now, finally, when it gets to that third item in our list, it's going to say, yep, it's equal. It comes around. Now it exits out after it finishes its loop. Comes down here, and we ask, did I find it? If that message is, find it is equal to yes, we get a message that says, hey, your item is in our warehouse. It could ship out. If it's no, we have it as a way to do that. So this is really just taking that array. So now we can think about it having a lot of details and information. So if you're a Dungeons and Dragons fan, does anybody play Dungeons and Dragons? Anybody that nerdy or something similar to it? You have like all these things. If you play a game, do you have like Call of Duty? You have weapons. Yeah, let's use Call of Duty. You have a list of weapons. This is searching through your list of weapons, and it's all stored on one array. That way we look through there. So this isn't very efficient, and already you should already say, well, if it finds it the first time, why do I have to run this loop another 5 times? But we'll get to that. It works. It's not always necessarily the most efficient. Because it could be very well that the first item in our array trips that find it flag. It's still going to run that, right? So we'll clean up some language and clean up that a little bit. But this is what we're looking at. Why those arrays are really, really handy is it gives us a way to deal with sets of data. And sets of data are kind of nice. So here it is in the pseudocode, the same thing. So here we have our start. We have put all our comments in there. So item available, item not found. And here we have that loop that searches through to see if item is equal to valid item. So that just searches through that loop. So we may be asking for a specific item. If it never finds it, if it doesn't find it, so we're looking for item 404, doesn't exist in that list, it's never going to change this find it to a yes, and it's going to come down to this if-then statement, and it's going to say else output message no. We don't have that item. Item not available. All right. I think I'm going to stop here and talk about parallel arrays. So if I can use those subscripts, this is a really neat way, and this is kind of the beginning of how we start looking at databases and how they're actually built, is this idea of parallel arrays. You have to read the book on this chapter. We have an assignment this week that will tax your brain a little bit when we start thinking about it. These parallel arrays are a whole new way, and arrays are a new way of storing data. We've probably never done this before, unless you've done some coding before. But a parallel array or an array is just a way we store buckets and buckets and buckets of data. When you did algebra, X didn't have 12 different possibilities. It has one value. Now we're adding this idea of these subscripts to it. And that subscripts or that index, we could put 1,000 different items in one variable. And how do we start dealing with it? And it's a good thing. So if I had the data, so I said I have a variable named student last name here at our college campus. With those arrays, I could hold 100,000 students in one variable. I don't have to have a variable for Nancy, a variable for Jim, a variable for Mark. I can have a whole list of them in there. So make sure you've read this. We'll talk about it and look at the homework a little bit on Thursday. There's a lot of material in this week to read through, and I've got some samples and all kinds of stuff in there for you to utilize. But you're going to have to utilize those fingers, utilize that brain a little bit this week. And then we're going to transition in the next week and a half or so to everything's going to be done in Python. So we're going to show you how we do arrays in Python. We're going to show you different data constructs like this. And luckily, Python makes our life pretty easy on arrays and other things. Other languages are much more complicated. Python basically says, here, make an array. We don't care how long it is, how big it is. Other ones, we have to explicitly say how big it is, and we have to run into some garbage collection and some other things. All right, any questions? All right, high school business contest is tomorrow, so this lab will be busy if you are on campus, and it's going to be kind of a zoo on our campus. So enjoy the high school students running around. All right, let's get out of here.